Hello everyone. Today I will present our work, Exotic, which stands for External Vision Guided Incomplete Multiview Classification. Let me start with the motivation. In many real-world applications, multiview data are often incomplete. For example, sensors may fail or objects may be occluded, causing some views to be missing. Existing incomplete multiview classification methods mainly rely on internal supervision signals, that is, they try to complete missing views using only the available data from other views. However, this approach has an inherent performance ceiling, because the semantic information is limited by the incomplete data itself. On the other hand, external knowledge, such as large-scale unlabeled images, is rich in visual semantics and is widely available. But it has been largely ignored in this field. So we ask, can we leverage external vision knowledge to provide additional supervision and guide missing view completion? Our key idea is simple but powerful. Instead of mining only internal information, we introduce external vision knowledge as semantic guidance. As shown in Figure 1, while existing methods are trapped by internal supervision, our exotic paradigm brings in external knowledge to enrich semantics and break through the performance limitation. Now I will walk you through the method. The exotic framework consists of four main components. First, external knowledge construction. We collect a large set of unlabeled images, such as a subset of ImageNet. For each image, we use blip to generate textual descriptions, then BERT to convert them into vector representations. This gives us a rich external knowledge library. Second, knowledge filtering. Directly using all external knowledge would introduce noise and irrelevant information. So for each sample, we compute the cosine similarity between its internal representation and all external knowledge embeddings, and we select the top k most relevant ones. Then we average them to obtain a sample-specific external knowledge representation. Third, knowledge purification. The filtered knowledge may still contain task-irrelevant information or conflict with the internal representations. To solve this, we introduce two losses. The category alignment loss ensures that the filtered knowledge is relevant to the classification task. The knowledge alignment loss aligns the external knowledge with view-specific internal representations, balancing both sources. Finally, external completion. We use a dual-channel decoupling architecture. Channel 1 focuses on knowledge filtering and purification, while Channel 2 handles representation learning and classification. The purified knowledge from Channel 1 is used to impute missing views in Channel 2, replacing zeros or simple averages with semantically meaningful information. This decoupled design prevents task interference and ensures stable training. Finally, let me show you the experimental results. We evaluated Exotic on 7 widely used datasets, including Caltech 101, Scene 15, and others, under missing rates from 0.1 to 0.9. We compared against 10 state-of-the-art incomplete multiview classification methods. As shown in Table 1, Exotic consistently outperforms all competing methods across all missing rates. More importantly, under high missing rates, say 0.3, 0.5, 0.7, and 0.9, our advantage becomes much larger. The performance drop of Exotic is the smallest, demonstrating strong robustness. Figure 4 provides a TSNE visualization. Compared to zero imputation or mean imputation, our external knowledge-guided completion produces much clearer interclass boundaries, meaning more discriminative and semantically consistent representations. We also studied the impact of external knowledge sources and sizes in Table 2. As the knowledge library increases from 100 to 50,000 samples, performance steadily improves and eventually saturates. Even cross-domain knowledge, such as cartoon images, achieves competitive performance, showing the generalizability of our approach. Finally, the ablation study in Table 3 confirms that each component, the knowledge alignment loss, the category alignment loss, and the external completion module, all contribute positively to the final performance. In summary, Exotic is the first work to use external vision knowledge as supervision for incomplete multi-view classification. It effectively filters, purifies, and leverages external knowledge to impute missing views, achieving state-of-the-art performance, especially under high missing rates. Thank you.